Hello students, in this lecture uh, for the uh, distributed software engineering, we are going to discuss the architectural patterns which are used in development or used in the development of the distributed systems. Okay, they are basically uh, uh, the framework which are normally used for different kind of development of distributed systems in case of the distributed software engineering. So, uh, the widely used architectures in distributed software engineering are like Masterslave architecture, two-tier client-server architecture, multi-tier client-server architecture, distributed component architecture, peer-to-peer architecture. Okay, so in the Masterslave architecture, it is basically used for in case of the development of real-time systems which are distributed in nature. So where the interactions are uh, there are guaranteed interaction response times are required. So similarly, for two-tier client-server architecture, which are basically simple client-server architectures, uh, and where the security is of utmost importance. Okay, and similarly, multi-tier client-server architecture, which is used when there is a high volume of transactions to be processed by the server. That is, the multi-tier client-server architecture patterns are used where there is a very high volume of transactions involved. So similarly, distributed component architecture, when there is a when we need to use, that is when we have to combine uh, the databases which are used in the case of to access different resources, and also as an implementation model for multi-tier client server systems. Okay, and similarly we have a we can use the architecture pattern for peer-to-peer architecture where there is no server is very limited in nature, where the clients directly interact with one another. That type of architecture is called as the peer-to-peer architecture. Okay, so we'll discuss these architecture patterns one by one in detail. Now, this master-slave architecture is basically where when we have to develop a real-time systems, the distributed architecture or the distributed system which needs to be developed is real-time in nature. That means the response time is uh, very fast. So we have a very real-time response systems for the clients. So it is so master process is usually responsible for computation, coordination, communication, and it controls the slave processes. Okay, the slave processes are dedicated to specific actions such as acquisition of data from the array of sensors. So now in such systems, normally the slave processes, they are basically tasked at the acquisition of data from the sensors. Okay, so and master process is basically used for the computations and the um, other processing of the task which are sent by the slave process. So here is an example of a traffic management system as the master slave architecture, where there are the master is you can see in between. This controls the slave processes, that is the light control process and the sensor control process. Okay, both are two slave processes where one controls the traffic light, another controls the sensors, which basically uh, determines how much traffic is available. Okay, and accordingly the lights are being controlled. So in between the master process exists, which basically controls both these slave processes. Okay, and coordinates the slave processes. Another architecture is basically the two-tier client-server architecture, uh, where the system is implemented as a single logical server plus a large number of the clients, okay, that use the server. Now, in this kind of architecture patterns, there are two varieties. One is called as the thin client model, another is called as the fat client model. As you can see, here's the thin client model and the fat client model. Now, in the thin client model, the the clients only holds the presentation layer. Okay, presentation layer is implemented in the clients, whereas the server implements most of the activities like data management, application processing, and the database. Okay, is implemented on the server. Unlike this, in the fat client model, the sum all the application processing is carried out in the client. Okay, so only data management and the database functions are implemented in the server. So most of the application, in this case, most of the computational tasks and most of the uh, application processing is carried out in the client side, where only the few tasks like database management, etc., only are carried out in the server. So this is the diagrammatical representation of thin client model and the fat client model. In the thin client model, you can see is the only the presentation layer is implemented in the thin client model. There's a client side, whereas database, data management, application processing all are implemented in the server side. Whereas in the flat client model, the presentation and application processing both are implemented in the client side, and database management is used in the server side. Okay, so that is how it is different. That is the difference between thin client and the fat client model. In the fat client model, the server is tasked with more tasks like application processing, etc. Whereas in a thin client model, the client side is very lighter one. Most of the activities is performed on the server side. Most applications of the thin client model is there when the legacy systems are migrated to the client server architecture. Okay, so in such cases, when legacy systems are migrated, we can say the legacy system acts as a server on its own right, and only graphical user interface is applied on the client side. Okay, the major disadvantage of this approach or this particular architectural pattern is that the server is given heavy processing load. Okay, and the network is also overloaded. In the fan client model, more processing is delegated to the client side as application processing is locally executed. Okay, so most of the new client server models have the capabilities of uh, deploy this actually fat client model is implemented in the new client systems where we know in advance the capabilities of the clients. Okay, so so that's why in the most of the new system client server systems the fat client models are used, and this fat client model is basically more complex than the thin client model. And also, when we implement the fat client model, basically uh, newer version or the new version of the applications have to be installed in all the clients to have the full capability of execution of the or the processing at the client side. Okay. The fat client model can be demonstrated with the client server architecture of an ATM system, where the most many of the processing are actually done on the client side. Okay, and then we have the mainframe server as the backend system of the ATM networks. Okay, so here you can see the account server where we have the two parts teleprocessing monitor and the customer account database, which are the mainframe computers which holds most of these databases, and most of the uh, the processing of the client data is done on the client machines only. Okay. So you can see the descriptions here. So server is a mainframe running on the customer account database. Okay, and software in the teller machine carries out a lot of the customer related processing associated with the transaction. That's why that's the fat client model. Okay, a teleprocessing monitor is a middleware basically uh, that organizes communication with the remote client and serializes the client transaction for processing by the database. Okay, so this teleprocessing monitor, as you can see, the teleprocessing monitor, this part, this comes as a middleware. Okay, that helps in transmitting uh, the locally processing task or uh, the application processing that is done on the application client is passed to the customer database. So in between comes this particular middleware, that is the teleprocessing monitor. So another type of architectural pattern that may be used is the multi-tier client-server architecture, where the different layer of the systems, namely presentation, data management, application processing, and database, are separate processes and that may execute on different processors. Okay, so we may have what different kind of layers which are segregated for different activities. Uh, that is the data management, application processing, etc. Okay, so this basically uh, if we use the two-tier client architecture, say thin client model in such cases, its scalability and the performance can be enhanced. Whereas if we use the fat client architecture, then you can have actually um, the problem of system management if the fat client model is used. So for these reasons, the multi-tier client server architectures may be used. As you can see, there is an example here of the internet banking system which is using the multi-tier architecture. We have the clients using the HTTPS interactions. Okay, there is the web server that actually provides the account service provisions. Okay, then the SQL query is basically through which the database server and the web servers interact. So this is a multi-tier architecture. So it's a three-tier architecture because there are the number of layers is three. So as the description goes here, that is uh, the architecture in between. You can see here the web browser, okay, web server. Basically, the web server in between, that is this particular server. What it does, it normally it provides the data management services, okay, such as web page generation and some application services. So these application services, like facilities to transfer cash, generate statement, pay bill, and so on, are basically implemented using the web server. Okay, uh, and they are basically executed by the clients by using the scripts. Okay, so users' own computer with the internet browser serves as the client. So different scripts are implemented in the on the client, based on those services provided by the web server. So with this kind of architecture, with the three levels, as you can see, different processes are being carried out in different layers. So in such architecture, it becomes highly scalable because suppose with the increasing number of the customer base, we can basically increase the number of web servers to have a better service for the customers. Okay, so this is basically the scale out of the system. Another part is to discuss about the distributed component architecture. So, unlike the client and the server system, that is the client server system, there is no distinction in the distributed component architecture. That is, every components are of the same, that is of the same capacity. So, in the distributed entity, each distributed entity is a object is the object that provides services to the other component and receives services from the other component. Okay, so uh, the each component is basically or each object in a distributed distributed architecture is basically the component of same capacity which interact with one another. That is, one provides a service, either provides a service or receive the service from the other component. And this component communication, the way the communication is done between from component to component, it is done through a particular middleware. Uh, and these distributed component architecture are more complex to design than the client server architecture. You can see the architectural diagram of a distributed uh, component architecture. So these are the component 1, component 2, component 3, component 4, and all provide some common services through the middleware to the client. So that is what the distributed component architecture is showing here. Now here is an example distributed system architecture for data mining system. Okay, so there are three databases: database 1, database 2, database 3. All, there is a component which integrates the databases, and there is also another component which is the integrator to integrate it. So integrator 1 and integrator 2 basically integrates these database components, and then the repository generator, report generator, and then the visualizer, and then the display. Okay. So through the integrator component, the visualizer receives the visual inputs, the inputs for visualization. Okay. So then there is a report generation which can be carried out, etc. So data mining is actually a system uh, which usually pulls the information from several separate databases and carries out computationally intensive processing and displays the result graphically. Okay, so it does this data mining component basically does the computationally intensive task. Okay, uh, and does the processing and display their results graphically. So, for instance, a relatively high proportion of people who buy the pizzas might also buy the crime novels. With this knowledge, the business can specifically target the customers who make specific food purposes with information about new novels when they are published. Okay. So this kind of information, basically, the interleaved information, it helps in the mining the database. Similarly, visualizer custom component interacts with the integrator components to produce a visualization or a report on the relationship that have been discovered. Okay? So about the relationship that have been discovered, a visual report uh, can be made with the help of the integrator component. The distributed component architecture basically suffers from two major disadvantages. Okay, one is that they are more complex to design than the client server architecture, because the distributed component architecture are basically difficult for people to visualize and understand. Okay, so that's why they become more complex to design than the client server architecture. So, and also it requires standardized middleware for uh, uh, actually it requires a standardized middleware components, but such components, availability of such components is very difficult actually to obtain. Okay, so uh, different vendors like actually Microsoft Sun have developed some, tried to develop such standard middlewares, but uh, ultimately they turned out to be incompatible. Okay. So as a result of these problems, basically, server-oriented architecture are replacing distributed component architecture in many situations. Peer-to-peer architectures are another kind of architecture pattern where basically they are decentralized systems where computations may be carried out uh, without much role from the server. Okay, so basically this kind of system or peer-to-peer architectures are designed to take advantage of the computational power of the and storage of the large number of network computers. Okay, so uh, the standard and the protocols that enable communication across the nodes are embedded in the application itself, and each node must run a copy of that application. Okay. Most P2P systems have been personal systems, but there is increasing business use of this methodology. So the P2P in the peer-to-peer network, mostly the all peer nodes basically connects, that the clients connects to uh, make it a decentralized architecture. Okay, so computational power is shared between the peer groups, whereas server plays a very minimal role in coordinating the clients. So in a peer-to-peer architecture, basically every node in the peer-to-peer architecture are aware of the every other node, where they exist and how they work. Okay, so nodes can connect to and exchange data directly with any other nodes in the network, because um, the informations are passed very frequently among the peer nodes. Uh, in a decentralized architecture, the nodes in the network are not simply the functional elements, but are also the communication switches that can route data and control signals from one node to the another. Okay, so they are not only considered to be they does not only behave as the functional unit or functional elements, these nodes, but they also can actually communication switches that can route data and control signals from one node to another. Okay. So in a peer-to-peer architectural model, basically is a logical network architecture, and they are decentralized architectures. So there can be semi-centralized architecture also within the network. One or more nodes acts as server to facilitate the nodes communication. This reduces the amount of traffic between the nodes. Okay. So if we have a uh, particular node, some nodes which are designated as the server to work with some limited power, then we call this the semi-centralized architecture. So application architecture, the generic organization of the components making up a P2P application, so that becomes the application architecture. So basically, the focus of this is to discuss the uh, network architecture. So we can see here a example of a decentralized peer-to-peer architecture. So we have some peer nodes communicating from one node to the another node. Okay. Similarly, there are two broad categories of the peer-to-peer architecture here. Okay, where there is only one communication between the M3 and M6. Suppose if someone needs a document that is stored somewhere in the network, okay, that particular node can actually issue a search command, and which is sent to the node in their locality. When the document is finally discovered, the nodes holding the document basically uh, can send it to the requesting node directly by making a peer-to-peer connection. Okay, So in peer-to-peer network, such documents are directly shared from one client to the another client. So this architecture has the very big advantage is that they are highly redundant. Okay, so hence they are fault tolerant. So that is a big advantage for the decentralized architecture. Similarly, there is a disadvantage also. Many different nodes may process the same search, and there is also a significant overhead in replicated peer communication. So since uh, there are many communications which takes place among the peer nodes, so there is a possibility that same search or the same processing will be carried out again and again. Okay, so that actually carries a significant overhead. So a semi-centralized peer-to-peer architecture can look can be of this sort. That is where you have the number of peers, as you can see, which are connected among themselves. Okay, but then there is also a super peer, which basically coordinates the activities of these peers. Okay, so the role of super peer is to establish contact between the peers in the network. Okay, and to coordinate the results of computation. So they take initiative in establishing contact between the peers in the network and also the coordinate the results of the computations. Okay.